Today, we're diving into a real-life scientific detective story. I mean, this is a mystery that went unsolved for 50 years, and it's been devastating honeybee populations all over the world. This quote here from bee expert Dennis von Engelsdorp really just says it all. Before this parasite, you could just have bees. But after the Varroa destructor mite showed up, well, it changed the entire game. Now you have to actively fight just to keep them alive. And let me tell you, this was not just another bug. This thing was a whole different level of parasite. When it got to the US back in 1987, it took less than a decade to basically wipe out all the wild honeybee colonies. And the craziest part? For all those years, we thought we knew exactly how it was killing them. But it turns out, the official story was completely wrong. All right, so let's crack open this cold case file. For 50 years, I mean literally half a century, the story was always the same. You'd find it in every textbook, every expert would tell you, Varroa mites suck the blood of honeybees. Their blood is called hemolymph, and that was supposedly the mites' only food source. But here is where the whole story just falls apart. This fact, this cornerstone of our understanding, all came from a mistranslated Russian paper from the 1960s. Can you believe that? The original paper wasn't even about what they ate, it was about how much tissue they removed. But somewhere along the line, it got twisted into they eat blood. And nobody ever double-checked. So for 50 years, science was chasing a ghost down the wrong path. Okay, so that's where our detective enters the story. A grad student, Dr. Samuel Ramsey, comes along and asks a simple question. Are we sure about this? He started digging, and his investigation followed three main clues that started to pull the thread on this whole myth. So, clue number one, it was hiding in plain sight the whole time. It was all about the evidence the mites left behind, specifically their poop and, their plumbing, their digestive system. Okay, so look at this. If you're eating blood, which is mostly water, your waste is going to be liquid and watery, right? But what Ramsey found was dry, white crystals, the total opposite. And think about other bloodsuckers like a mosquito. They have these really specialized guts to get rid of all that extra water fast. The Varroa mite, it just has a simple little tube for a gut. No special plumbing, no swelling up when it feeds. It just didn't add up. And it gets even more interesting when you look at what those dry crystals actually were. They were purines. Now, if that word sounds familiar, it might be because of gout. In people, high levels of purines come from eating organ meats, like liver. So finding this in the mites' waste was a huge red flag. It suggested they weren't drinking a liquid, they were eating solid organ tissue. All right, on to clue number two, the family tree. Ramsey thought, hey, if this thing is a bloodsucker, then its closest relatives should probably be bloodsuckers too. It just makes sense, evolutionarily speaking. Well, surprise, surprise, they weren't. When he looked at the family tree, Varroa mites aren't even close to things like blood-feeding ticks. Their closest cousins are, well, they're kind of gruesome. They're the kind of mites that inject digestive juices into their host to liquefy their organs from the inside out, and then they just drink the slush. I know it's grim, but it was a really important piece of the puzzle. And that brings us to the third and final clue, the scene of the crime. Think about it. Blood is everywhere in a bee's body, so if that's what you're eating, you could bite anywhere. But if you're after one specific organ, you'd have to feed in the exact same spot every single time. And guess what? That's exactly what he found. More than 95% of the time, the mites were tucked into one very specific location, right under the plates on the bee's belly. This wasn't random chance. They were laser-focused on something right in that spot. And this is so important because it debunks a huge myth among beekeepers. We all have that image of a mite riding on a bee's back, right? Well, it turns out they only go there when the bee is already dying and the whole colony is about to collapse. They're just trying to hitch a ride to a new victim. So if a beekeeper is waiting to see mites on the bees' backs, it's already way, way too late. The house has already burned to the ground. Okay, let's put it all together. The evidence is piling up. You've got the weird, dry poop full of purines. You've got the gruesome, organ-melting cousins. And you've got them feeding in the exact same spot every time. All the clues were pointing in one direction. They are not eating blood. So the big question is, if it's not blood, then what is it? What's the one thing located right under that spot on the bee's belly? The answer? It's an organ called the fat body. Now, don't let the name fool you. This thing is like the bee's liver. It's maybe the most important organ they have. It runs their immune system, it detoxifies pesticides, it stores energy, it basically does everything. So, to prove this was the real target, the team came up with this brilliant experiment. They took some bees and injected them with two different fluorescent dyes. One made their blood glow yellow, and the other made their fat body tissue glow bright red. Then, all they had to do was let the mites have lunch. And the result? It was the smoking gun. They looked at the mites under a microscope, and what did they see inside their guts? Not a trace of yellow. They were glowing bright red, jam-packed with fat body tissue. That was it. Case closed. And just to be absolutely sure, they did one last test in the lab. They tried feeding mites different things. Mites that got a diet of just bee blood, they died just as fast as mites that were given nothing at all. But the mites they fed fat body tissue, they lived for more than a week and they were healthy enough to lay eggs. The conclusion was undeniable. Blood isn't food for them at all. So you might be thinking, okay, so they eat the fat body, not the blood. Why is that such a big deal? The bee's still being eaten, right? Well, it turns out that difference, it's everything. Think of it this way. For decades, we treated a Varroa bite like a mosquito bite. You know, it's annoying, maybe a little dangerous if it passes on a virus. But the new reality is so much worse. A Varroa bite is like something taking a chunk out of your liver. This isn't just an annoying pest, it's a parasite performing a live organ removal. And suddenly, all those weird, devastating symptoms that beekeepers were seeing in their hives made sense. When you attack the fat body, you cripple the bee's immune system. They can't fight off pesticides, their energy regulation goes haywire, their growth gets stunted. It's a total systemic collapse, and now we know why. The big takeaway here is just, wow. We have been getting the cause of death wrong for half a century. The Varroa mite isn't just a vampire sucking a little blood. It's a predator that is literally dissolving and eating the most vital organ a bee has to survive. But now we finally know the killer's true motive. And that changes everything. Now that we understand how this parasite actually kills, we can start developing treatments that target its real weakness. This discovery could finally give us a fighting chance to rewrite the ending for the honeybee and protect one of the most important animals on our planet.